Hello students, welcome to my channel Arun's Physics Portal. In this lecture, I will be talking about the voltage follower and its use. This topic is useful not only for BSc, MSc, BE, BTech students, but also for NET and GRF aspirants. The complete note of this topic is provided in this lecture for your convenience. So let us come to our topic. The voltage follower is made of two words. It is made up of two words. One is voltage, another is follower. So it is a device where one voltage follows the another. In particular, the output voltage follows the input voltage. So this is a special case of non-inverting amplifier. We have seen a non-inverting amplifier before. So this is the circuit diagram of a non-inverting amplifier. This is your Vs, this is your resistor Rf, and this is resistor R. So this is your non-inverting amplifier. If I make Rf equal to 0 and R equal to infinity, what I get is a voltage follower. We have shown it in figure 1. So this is the circuit diagram of a voltage follower. This is Vs, Rf is 0, so that input and output are directly connected. What is the meaning of R equal to 0? When there is a potential difference applied by a cell, and this is the point P and Q. No current will flow between the points P and Q because the circuit is open. A current will flow only when the points P or Q are connected somewhere and somehow, so that a current can flow and the loop is closed. Only then a current will flow. So if no current flows, then we have the current I is given by Ohm's law as V upon R. Since no current flows here in this circuit, so this is V upon infinity will be 0 only. So R must be infinity. That means the point Q and Q are not connected in any way. In this figure 1, we have the inverting input and the ground are not connected in any way. So the resistance R is infinite here. The gain equation of the voltage follower can be derived in the following way. At the non-inverting input, the voltage applied is Vs, and at the inverting input, the voltage is V0, because the output and the inverting input are connected together. So V0 is equal to A times Vs minus V0. That is to say, V0 into 1 plus A is A Vs. The gain of the voltage follower is thus AV equal to V0 upon Vs equal to A upon 1 plus A, or AV equal to 1 upon 1 plus 1 upon A. Since A is extremely high, it is of the order of 10 to the power 5, and therefore 1 upon A tends to 0. In such a case, the previous equation becomes AV equal to 1. Thus, a voltage follower is almost an ideal buffer amplifier because of its high input impedance and unity gain with no phase shift. वोल्टेज फॉलोअर एक ऐसा डिवाइस है जिसका गेन यूनिटी है और इसमें फेज शिफ्ट नहीं होता है, दैट मीन्स बोथ द इनपुट and the output voltages are in the same phase. So this is a special case of non-inverting amplifier with a gain of unity. इस voltage follower को हम source follower भी बोलते हैं. This is so because the output follows the voltage of the source voltage. This is also known as unity gain amplifier. ये ऐसा एम्पलीफायर है जिसका गेन यूनिटी है. This is also known as a buffer amplifier or isolation amplifier. This is because it is used to connect a high impedance source and a low impedance load. किसी भी voltage amplifier का gain bandwidth product हमेशा constant होता है. And since the voltage follower has a gain of unity, it provides the maximum bandwidth. अब ये देखने की बात है कि जब इसका गेन यूनिटी है तो व्हाट इज इट्स यूज एंड व्हाई इट इज यूज्ड. इसको समझने के लिए हम ये सर्किट देखते हैं. मान लीजिए ये हमारा वोल्टेज सोर्स है ES एंड लेट इट बी ऑफ 1 वोल्ट. ये सोर्स का रेजिस्टेंस है एंड दिस इज source resistance RS is suppose this is 90 kilo ohm. This is the load resistance in the circuit. So this is RL, this is 10K. So if I take the output voltage across the load, what will we get? See, in this circuit, the total resistance in the circuit is total resistance R is RS plus RL, and this is equal to 90K plus 10K. So this is 100K. So the current in the circuit is I equal to ES upon R. This is 1 volt upon 100K. So this is 10 to the power minus 5 ampere. So when this current flows in this circuit on the left, we have a potential drop across the source resistance RS, and that potential drop is equal to I into RS. So if you find voltage drop across RS, then you get I into RS. So this is equal to 10 to the power minus 5 into 90K. So this is 0.9 volt. So 0.9 volt drops across the source resistance, and the voltage available across the output across the load resistance is only 0.1 volt. This also follows from Kirchhoff's voltage law or loop law. So the voltage available across the load resistance is only 0.1 volt, whereas we have applied a source voltage of 1 volt. So to avoid this, and we want that the voltage available at the output across the load resistance should be 1 volt. To achieve this, we use a voltage follower. So see here how this is achieved. We have this is the voltage follower circuit. This is ES equal to 1 volt. This is RS equal to 90K. And this is the output voltage here, V0, and this is the load resistance RL. Now, this is the voltage follower. So the output, the ratio of output and input will be equal to unity. Because of the high input impedance of the operational amplifier, no current will flow through RS into the non-inverting input of the voltage based operational amplifier circuit. So when there is no current flow through the source resistance Rs, there is no potential drop across Rs, and therefore the total potential available at the non-inverting input is also equal to 1 volt, which is equal to your applied voltage here. And therefore the voltage available at the output V0 is also equal to 1 volt. So we see that by using a voltage follower in the circuit, we have been able to have a voltage of 1 volt at the output when the input voltage is also 1 volt. If I do not use a voltage follower here, then only 0.1 volt will be available at the output, even though we are applying a voltage of 1 volt by a source. So this is the beauty of the voltage follower circuit. I assume that you like this lecture. यदि आपको ये लेक्चर अच्छा लगा हो तो इसे लाइक करें, शेयर करें और मेरे चैनल को सब्सक्राइब करें. Thank you for watching. See you next time with my new lecture on some other topic of interest. Till then, goodbye.